Hello, this is Mrs. Stevens, and I apologize for my voice. It sounds like I've swallowed a frog, but please just bear with me. Okay, just a little review from yesterday when Mrs. Deacon taught this, lesson 817. We talked about that a reduction has a scale factor which would be less than 1. And an enlargement is going to get bigger. It's going to have a scale factor that is greater than 1. And just want to keep that in mind for today. We're just going to look at enlargements because we're going to compare actual lengths to scale drawings. So a scale drawing is going to be smaller, and we're going to look at it as an actual, what it would be if it was real life. So we're always going to be getting bigger today. So our first problem, and remember you can pause this at any time if people are running behind, just speak up. Because I'm going to go pretty quickly so I can get under 15 minutes so I can get this on YouTube. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with school administration, he is told it will be approved if it will fit on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he planned? Explain. All right, so first of all, here's our drawing, and we've got a scale here that says 1 inch on the drawing corresponds to 15 feet of actual length. Now, before our scale factor, we always said it had to be in the same units, so like inches and inches. But now we're looking at a scale drawing, and our scale is 15 feet is equal to 1 inch. So now we're just going to call it something a little different. We're going to call it scale ratio, which is really the unit rate. And for this one, our scale ratio is going to be, we're converting to feet, and so we know it's got to get bigger. So this, the feet, is going to be 15 feet is going to be our numerator because our enlargement depends on our actual picture drawing. So this is the dependent variable, so this is like the y, and that's going to be per 1 inch. So that's the same thing as 15 feet per inch, just like if you do miles per hour, it's a unit rate. So we're going to take our unit rate, and we're going to look down here at our picture, and we know, well, if there's 15 feet in an inch, let's look at the 2 inches. That's easy to look at. So halfway across, that would be like 1 inch. And here's another inch. Now this, of course, is not to scale because I enlarged it so you could see it. But if I have an inch here, and we know that 15 feet is equal to an inch in real life, then on the actual court, that would be 15 inches and 15 more inches. So 15 and 15 is 30. Well, all we're doing here then is taking what used to be called scale factor, which we're now calling scale ratio, and we're going to multiply that by 15 feet per inch. And when we do that, of course, 2 times 15 is 30, and it's going to be 30 feet because we're looking at what it is going to be on the court or in the lot. But I want to look at the inches for a minute. I've got an inch here, and I've got feet over inches, kind of like a fraction. It really is a fraction. Well, I could make inches a fraction by putting inches over 1. And now I've got inch in the denominator and inch in the numerator. Well, these are alike. So just like a variable or just like a common factor in number, we can divide these out. And inches divided by inches is 1. The inches are gone. And 1 times 2 is 2. So the 1 is gone. We don't really have to have it since it's all multiplication. So that's going to be 2 times 1 times 15 is 30, times feet, well, that's just leave the feet. Inches, I've got a 1 here, not inches, and I've got a 1 here, so the denominator's 1, so I don't have to write it. So we know it's 30 feet across. We're going to do the same thing for 1 2/3 inches. We're going to multiply it by our scale ratio of 15 feet per inch. But now we've got a mixed fraction. So we're going to rewrite that as an improper fraction. So we go 1 times 3 is 3, plus 2 is 5/3 inches. times 15 feet per inch. So now I've got 5 over 3, well, I can make 15 over 1. And I've got inches and feet over inches, so I can make inches over 1. Well, let's look at the numbers first. I've got a 3 in the denominator, and I can divide out a common factor. So divide the 3 out there, common factor of 3 here. So 15 divided by 3 is 5. Now I can divide out an inch here and an inch here, so I've got 1 and 1. And then if I multiply straight across, I've got 5 times 1 times 5 is 25, and then I've still got my feet. And then in the denominator, I've got 1 times 1 times 1 times 1, which is a 1 that I don't have to write. So now when we look at this court, okay, it goes 25 feet in the lot by 50 feet. Well, that means this 25 feet will fit within there because 30 won't. So we can say our court is going to be 25 feet by 30 feet, which will fit in the lot because 25 feet fits within the 25 feet, or the 25-foot lot, and the 75 or the 30 feet fits in the dimensions that go 75 feet for the length, even though we want to call that the width. It still fits. We just would put it in there and put this side with the 25, or I'm sorry, yeah, this side with the 25, and this would run, it'd be 75 feet. We'd only have to use 30. All right, next example. Now we've got a garden, and in this garden, the scale is 1 centimeter for every 20 meters. Each square in the drawing is 1 centimeter by 1 centimeter. So 1 centimeter by 1 centimeter. But every 1 centimeter is 20 meters. And they want us to find the actual length and width of the garden based upon the drawing. Well, if this is 1 centimeter, we know that's the same thing in real life as 20 meters. So if I put 20 meters there, 20 meters here, 20 meters all the way across, because each one of those is a centimeter, and I'm just going to put ditto marks to mean same thing. And then, of course, this is 1 centimeter, so I've got 20 meters all the way down the width. So let's find the length. Well, the length here, there's 1, 2, 3, 4, 5, 6, 7, 8, and those are centimeters. So we've got 8 centimeters times 20 meters, and my scale ratio would be 20 meters per 1 centimeter, because we're going to get bigger. And so now I multiply, I get 80, or 8 times 20 is 160. And then I can put centimeters over 1 and divide out my centimeters, common factor. So it's 160 meter length. Now if we come over here and do the width, it goes 20 all the way down. Well, there's 4 centimeters all the way down. If we multiply that by our scale ratio, that's going to be 20 meters per 1 centimeter, centimeter over 1. 4 times 20 is 80. The centimeters divide out, and I'm left with 80 meters. Okay, so the dimensions, the actual length and width, this is the width. And here's the actual length of the real life garden. And again, remember, you can pause as we're going along, because I'm going really, really fast. Okay, so we got a graphic designer, and they're creating an advertisement for a tablet. She needs to enlarge the picture here so that it'll be 0.25 inches, or 25 hundredths of an inch on a scale picture will correspond to 1 inch on the actual advertisement. What will be the length and width? So we're going to need, first of all, I'm going to look at this as a table, just because it gets confusing when we're doing 0.25. So we're going to look at the picture, or the original, and then we're going to look at the advertisement. I'm just going to put ad there. That's the enlargement. And we know that the original picture is 0.25 inches, which really is the same thing as 1/4 of an inch. And then we've got 1 inch for the enlargement. Okay, so when we look at that, the unit rate, which would be the same thing as the scale ratio, remember the enlargement always in these depends on the original picture. So y is dependent, x is independent. So we're going to do k is equal to y over x. So that's going to be 1 inch over 0.25 inches. If you divide that, you're going to get 4 as your scale ratio. And notice it's inches for 1, and that's the inches of enlargement. So here they're the same, so I'm going to just label them. And then the 0.25 is the original, so I'm going to put inches orig for original. So that's 4. So that's going to be enlargement inches, and this is going to be original inches. Another way to look at this, because I know some of you are saying, how did you get 4? Well, you can just divide on your calculator, but that's also 1 divided by 1/4, and we divide by a fraction. That's the same thing as multiplying by the reciprocal. And then we just keep our same labels here. So you still have 4 over 1, or 4, enlargement inches over original inches. So now we're just going to multiply them. So we're going to do 1 1/8 times 4. Okay, so 1 1/8, that'll be 8, plus 1 is 9/8 times 4. And remember, this is the inches of the original. And this is enlargement inches over original inches. So when I multiply these, I can put 4 over 1, and I can divide out of 4. So there's 2 and 1. And then I can divide out the original inches, so I'm left with 9 times 1 enlargement inches. We're going to do the same thing with 1 1/4. So we're going to go 1 1/4 times 4. So that's going to be 5/4 times 4. And we can divide out the 4. And so that's going to be 1. So that's going to be 5. And it's going to be the same label. We would cancel out the same way. So that's going to be enlargement inches. All right, so it's going to be 9 inches by 5 inches is going to be our enlargement. The last one, okay, we've got students from a high school, and you can read this to yourself because it's so long and I'm running out of time. So pause the video and read that out loud together. And then when you come back, we'll look at this. Okay, so good to have you back here. And so here's our scale over here. So we're going to say that we have our actual distance here, and that's what we're trying to see if that's going to be able to fit inside 10 feet. So my scale is going to be 4.5 feet per 1/8 inch. And again, this depends on our picture, and so this is our independent variable, so it's like the x, this is like the y. So that's going to be, if I divide that out, 4.5 is going to be the same thing as 9/2 feet. And then I would divide this by 1/8, which is like multiplying the reciprocal, 8 over 1. And we're still doing feet per inch. So when I multiply those, I can divide out the 2, and I get a 4 there. So that's going to be 36 feet per inch. Okay, so it's 3/8 of an inch in the picture. So I'm going to take 3/8 of an inch and multiply it times my scale ratio, which is 9 feet per inch. And so now I'm going to multiply straight across because there's nothing to cancel in the numbers. So that's going to be 27/8. And then I can divide out the inches. So it's going to be 27/8 feet. Well, I need to look at that and see what that would be when I divide it. So 8 will divide into 27. There would be 3 in each group. And then there would be, that's 24, so there'd be 3 left over. So 3 3/8 feet. Oh, what am I doing here? I'm sorry, I'm multiplying by 36. All right, so if I multiply by 36, I'm sorry, I can actually divide out of 4 here and get 2, divide out of 4 here and get 9. So it's actually 27 over 2 feet. Okay, and those still divide out. So 27 divided by 2 is 13. and then you have a half leftover feet. Well, that's not big enough to fit through the 10-foot door. So no, it won't fit. And down here, what's the scale factor? It's right here, and it tells us how the picture compares to real life.